Good morning. Today we are going to transition into a new unit, and this unit is all about quadratics. And as with most units, the very first thing we're going to look at is a visual representation of quadratics, which in other words means graphing. And we are going to actually take a couple of days to look at how to do graphing of parabolas. Parabola is the shape that a quadratic equation or quadratic function makes. And we're going to look at two different ways to write the equation of a parabola, but today we're going to look at standard form. So this is standard form, y equals ax squared plus bx plus c. It's important to know that a cannot be 0. Why can a not be 0? If a is 0, then that means that there is no x squared term, and we would just have bx plus c, which is a straight line. So it can't have a equal to 0. Also, the shape of a parabola is either as a U shape. So when we look at one like this, where the a value is greater than 0 or positive, the parabola is going to open up like this. It's going to look like a U. But if a is negative or less than 0, it's going to make like a sad face, and it's going to open down. Also important to know is that the axis of symmetry is given by the equation here. That's using these values of a and b. And the axis of symmetry is important because a parabola doesn't look like this on one side and then this on the other, or this on one side and then this on the other. It's perfectly symmetrical. There's an axis of symmetry that going through it that if I were to fold it along that dotted line, the parabola would line up over itself. And then we find the vertex, which is either the maximum if it opens down or it's the minimum if it opens up, is given by this point. Really what this means is that we just take the value of the axis of symmetry, and that's our x value, and then we plug that in to get the y value. But I'll show you how we do that in a minute. And finally, the number at the very end is our y-intercept, which could come in very useful. So graphing y equals negative x squared plus 4x plus 2. First of all, is it going to open up or down? Because the number in front of x squared is a negative, it is going to open down. So that's a good place to start. But we're going to find and graph the axis of symmetry. So to find the axis of symmetry, or the AOS, we do x equals negative b over 2a. So I'm going to put negative, and then b is 4, and a is negative 1. Notice that the negative sign did not account for the negative that was in front of x squared. It's always there in front, no matter what your b and a values are. So this would be like having negative 4 over negative 2. So that's going to give me x equals a positive 2, because two negatives make a positive, and 4 divided by 2 is 2. So my axis of symmetry is not actually part of the parabola, but I put it on the graph because it helps me to see that that is where my line of symmetry goes. Next, I'm going to find and graph the vertex. So I know that my x-coordinate is 2, and the axis of symmetry says to take your x-coordinate and plug it in to the equation to get y. So I get y equals negative 2, I don't know how that happened, 2 squared plus 4 times 2 plus 2. Now be very careful here. What value do we get when we simplify this? A lot of people want to put that negative with the 2, but it's actually saying that we have negative 1 times 2 squared. 2 squared is 4, and 4 times negative 1 is negative 4, plus 8, plus 2. So this would give me 4 plus 2, which is 6. So y would equal 6. And I would write my vertex as an ordered pair. My x-coordinate is 2, because that's what I got up here, and my y-coordinate is 6. Your vertex should always be on the axis of symmetry. Your vertex should always be on your axis of symmetry. So I'm going to put my point right there. And I know that it's got to open down. So I'm going to find another point. Find and graph the y-intercept and its reflection. And this is why the axis of symmetry is so important. My y-intercept is just the number at the end. So my y-intercept is going to be, it's always 0 for the x, but then it's 2 for the y. So I'm going to put that here. But the axis of symmetry says that if I'm 2 away here from the axis of symmetry, I can go 2 over to this side. Now, I am mean because I make you find 2 more points because you have to have 5 points on your graph for it to be complete. So I'm going to pick another value of x and graph it and its reflection. What do you think would be a good value of x to plug in? It can't be 2 because that's my vertex, and it can't be 0 because I've already done that. I would go ahead and pick 1 because 1 is between my vertex and my y-intercept. I could pick something like -3 or 8, but those numbers are going to go way off of our graph. And so if I pick x equals 1, I know that it has to be somewhere in between these 2 points, because my graph can't go like this. It would not be a parabola then, or it can't go like that and come back up to it. So let's plug in x equals 1. And we get y equals -1 squared plus 4 times 1 plus 2. So this would give me y equals -1 plus 4 plus 2. So it'd be 3 plus 2, which is 5. So I've got the point 1, 5. So I'm going to go over 1, up 5. And then I'm going to graph its reflection. It's 1 away from the axis of symmetry, so I'm going to go 1 in the opposite direction from the axis of symmetry. And there's my point. My final step, sorry I wrote over it, but it's to sketch the curve. I didn't leave myself a lot of writing room on this one. And I'm not going to be too picky. I should see a curve though. There should be no point at the vertex. It should be a curve. So what I usually do is I kind of like start at 1 like that and then just go like this and then continue it. You should have arrows on either end. If it's not a perfect parabola, that's okay. Although if I do say so myself, mine's looking pretty good. All right, so that is how to graph a parabola in standard form. So let's look at the next one. All right, first of all, is this parabola going to open up or down? Because the number in front of x squared is positive, it is going to open up. Then we are going to find and graph the axis of symmetry. So find and graph the axis of symmetry and then check your answer. So what I need to do for the axis of symmetry is x equals -b, so -2, which sounds silly, over 2 times 1/3. Don't freak out just because there's a fraction. It's all going to be okay. I'm going to go ahead and cancel out those negatives and say I've got 2 over 2/3, but really this means 2 divided by 2/3. So I can rewrite this as 2 times 3 over 2. Cancel those out and I just get 3. So my axis of symmetry is x equals 3. It is important that you write it as an equation. The axis of symmetry is not just 3, it's x equals 3 because it's actually the equation of a line. So I'm going to draw this there. All right, what would be our vertex then? When we use our axis of symmetry, what do we get for our vertex? For our vertex, we're going to take 3 and plug it in. So I get y equals 1/3 times 3 squared minus 2 times 3 minus 3. So 3 squared is 9, and 1/3 of 9 is 3. So I get y equals 3 minus 6 minus 3. And y equals -3 minus 3 is -6. So my vertex, because I need to write it as an ordered pair, is 3, -6. So I go 3, and it should be on my axis of symmetry, so that's good. -6. All right, so then what is going to be our y-intercept? Our y-intercept is going to be the point -3 because it's the number that's at the end. Remember, the y-intercept is when we plug in x for 0. So if I plug in x for 0, it's like this goes away and this goes away, and all we're left with is -3. So that's why we can do that. So I'm going to have a y-intercept of -3, and then I'm going to graph the reflection as well. But I still need one more point and its reflection. So what value of x would you recommend plugging in? I'm going to plug in x equals 1 again because I like the smaller numbers. It does not always have to be to the left of the vertex. It just so happens this time that it was. I could plug in 4 or 5. I'm just being lazy and picking a smaller number. So I look at what are my options, and then I try to pick something close to it, but not too big of a number. Sometimes that just can't be helped. So x equals 1 would give me y equals 1/3 times 1 squared minus 2 times 1 minus 3. So this would just give me 1/3 minus 2 minus 3. But if I make these be over 3 so that I can add and subtract, I would get 6/3 and 9/3. So I'd have 1 minus 6 is -5. -5 minus 9 is -14/3. So I'm going to go to x equals 1 and then -14/3, which is almost at -6, or sorry, almost at -5, but not quite. Uh-oh. All right, and then last step is to connect our dots. Right. And that would be our parabola. Guys, that's all I've got for you today. Make sure that you follow those steps, and if you follow those steps, you won't really go wrong, I don't think. I think you'll be all right. Let me know if you have any questions, and I would be happy to give you more examples if you need them, or clarify any of the steps if they were confusing to you.